All right. Yeah, so thank you everyone for coming here. It is really good to see everyone. And thank you for the invitation to be here. It's really a pleasure to be able to come here and share with you my observations about the changes in the mining industry relative to tailings management. So these observations come from my experience in projects and review boards in four continents for a number of clients in the last decades. My career has been mostly as a consultant, so that's where my comments come from. So, as all of you, we're all pretty shocked with the failures that happened in the last, well, by now about 10 years. So there's a lot of pressure from society, from investors, from the industry, and that led to the GISTM, followed by guidelines and changes in the regulatory environment in many countries. Um, but most importantly, I think what I'd like to highlight is that there has been a change in the mining industry culture and practice. So it's a pretty important time for us to be in mining. So we're going to talk about the progress we made so far. And by the way, I'm pretty optimistic about the changes that happen in the direction that we are taking as an industry. And I will share my perception of the challenges that are still ahead of us. And I'll propose a few points to think about as we consider where we should go from here as an industry. So there has been progress in many areas, including governance, technical developments, creation of knowledge bases, and public disclosure and social engagement. So I'll speak a little bit about each one of them. There has been pretty broad adoption of the GISTM, which I find really encouraging. Um, both this adoption has been both by ICMA members, um, because it is a requirement of their membership, but also by non-ICMA members as a voluntary implementation. And it has created a step change in industry. And there are also companies that are not really adopting GISTM, not formally adopting it, but adopting significant components of it. And I think this all contributes to what we are saying as a step change technically, but also a cultural change. So, in my view, one of the most important and significant developments in the industry has been the evolution in tailings governance. So, the requirement that the board of directors publish a policy on safe management of tailings, and that has been implemented by many companies, it's pretty important. This is an overarching guidance that sets the safety of tailings facility, and and is a very significant change that happens. And it is a very important achievement to have tailings management elevated to this level of consideration with the involvement of boards of directors. For those of us in industry for several decades, we came a long ways. When I'm sure above a certain level, people didn't barely knew what tailings were. So, and given the magnitude of the risks that can be involved in tailings, the GISTM requires a few new things. And one of them is that tailings management reports to a very senior individual in the executive team, the accountable executive, who has authority and accountability for the integrity of tailings facilities. So the accountable executive, as per GISTM, is somebody who reports to the company CEO and has a direct connection to the board of directors. So there is authority and accountability to make things happen, but in fairness to the directors, they also get a direct line of communication. And the ITRBs also have a direct line of communication to the accountable executive. So it's not the message passing too many levels in the organization, and it gets there. There is also the implementation of the role of the responsible tailings facility engineer, who's somebody with engineering degree and experience to keep an eye that all the objectives of the tailings facility are being met. And that's pretty good progress. There has also been the establishment of the role of engineer of records in jurisdictions that didn't have that tradition. It's probably still a learning curve in certain areas of the world, but it's been really good progress. And all of these changes in governance and cultural had an impact of moving tailings management from being pretty much asset-centric, where each operation looked after the tailings management, to be more portfolio-centric, where the corporation has an eye on what's happening that. And I think that there is a lot of advantages on the corporate participation because there has been the establishment of corporate requirements and guidelines for tailings to have a more uniform standard of care and technical standard, which is of particular value in the jurisdictions where the regulatory level or the technical level is not quite as high as other places. But also, it gives more opportunity for professional development of staff, both in all of the sites, and as there is also more collaboration across sites. So it is good for the companies, it's good for the individuals. And corporate support on risk issues also has the advantage of um, people in the operations, they have to focus more on the day to day. Like it's very important, it's their job. So sometimes it can be very busy and very hard to step back and think about the big picture issues. So it's been a very positive change. Also, there is review boards, independent review boards, which used to happen in many places, but now they are requirements. So it's been used for more in more cases. And that also can promote more learning because the review board will share experiences that people in the review board had elsewhere. So there is more that cross fertilization. So good opportunity for everyone. Now, for our review boards to be effective, there are a couple of important things in addition to the selection of appropriate board members who have had the experience for the things that are issues in each particular project. Um, the most important one, in my view, is that there is an environment of collaboration and learning, free sharing of ideas, so the issues can be discussed, the problems can be discussed, so the best decision can be made. So everyone must operate in an environment of full transparency. As we say, it is a good place to come and wash the dirty laundry. If there are problems, things that people don't know, things that are not going right, that is the place to have that discussion because that is what allowed the review board members to use their expertise and their experience to help that team, to help the risk management. So it's an opportunity to learn, but those are exactly the issues where the review board can be of help managing issues. So governments now also plays a role here because in the cases where the people who present to the review boards, department managers, consultants, or whoever within the organization has KPIs that are related to the review board. I've seen cases where the review board report wasn't very positive, so negative mark on your KPI, or you had too many recommendations. That is a governance structure that doesn't support the members of the team to come up with the problems, which is really what needs to be discussed, right? So more progress, a lot of technical advancement in tailings processing, in tailings characterization, in characterization of the deposit behavior. So that's been really good. There is a culture more now of continuous learning and improvement, which is very important. Repeating past mistakes is unacceptable and very difficult to defend these days. Um, so studying case histories, learning what happened, all very important. And there are many other areas that we made progress. I listed a few here, but you probably know more than those for sure. There has been a lot of engaging discussions as well in topics that are still in development. Arguably, dam breach analysis is still new and evolving. Several other things, characterization of unsaturated tailings, the list goes on. Risk assessments, how best to implement ALARP. So I think we're really making a lot of progress. Okay, knowledge-based development, that is a requirement of the GISTM, and it's something that is growing, is increasing. If you ever had the experience of having to assess the cause of facility failures, um, or read the reports that are out on the failures that happen, one difficult lesson for us as an industry is that the lack of easy access to existing available information was a contributing factor. That's a tough one for us, especially in these days where it's so easy to create a knowledge base online with access for everyone, right? So it is critical for risk management because you don't want to have there information that could resolve or could minimize a risk and it was not used because it wasn't accessible. Also, it's time and cost efficient. I'm sure all of us had the frustrations of unproductive time looking for reports, looking for data, and forwarding this to people. So have a site where everybody can go, everybody can look. Um, Also, if you have a detailed construction record that is also acceptable, that is really critical to respond to emergencies. I had that experience. Is nothing worse than you have to give a solution to an emergency, but you don't know what was built. People in the team can't find the reports. You don't have any drawings. So there is a need for that information to be available so it can support fast and solid decision making in an emergency that can prevent a failure. Public disclosure and social engagement, I'm listing as another area of development. The GISTM really supported interdisciplinary conversations, but I think it's hard work. Cultural factors are very predominant, so it continues to evolve. We need to learn more, but also communicating risks is something that we need to learn more about. Okay, did I skip a slide? I did. Okay, so this is the progress that I'm seeing. So let's talk a little bit on the challenges still ahead. So I'm flagging four things. I'm sure we could all find more. So shortage of tailings professional, I think it's possibly the most significant challenge that the industry has right now. Shortage of qualified tailings professionals in all roles, at all levels, but probably in particular at the more senior level. It wasn't too long ago until tailings finally got established as a career path. Tailings engineer professional that didn't exist, surprisingly, not that much time ago. So there is there is a limited number of experienced professionals, and that can hamper the progress. It limits mentoring, and the situation can be aggravated by what people are calling the silver tsunami, which is people forecasting a number of more senior people retiring the next few years. So there have been a lot of papers recently identifying, quantifying the shortage of EORs, but I don't think it's limited to the EORs. It's limited to like all levels and all types of tailings professionals. So we need more initiatives to attract people to our industry and to the tailings area in particular. So here's some ideas to deal with that. I think we need to be very intentional in creating opportunities to accelerate career development for folks in mining and tailings. Things like it could be rotating people through projects in a well-considered manner so they enhance particular skills that they still need, see different things and foster their career, but while maintaining appropriate project support and appropriate continuity for every project. So we could be a bit more intentional that way. also more intentional in supporting an environment of mentorship and open discussion. Um, Decisions relative to contracting specialized tailings work, and maybe here I'm talking about more about the owners, more of an issue in some cases than others. They can't be purely done by contract and procurement personnel. These people definitely have a particular expertise that they bring to the process, but I don't think it's fair to expect that they can discern what is the specialized service for that particular project. They don't have the technical background to evaluate whether a particular individual company um, has the skills for that particular project. So I think we need to work as a team with them a little bit more because hiring engineering that's not sufficiently qualified for the degree of complexity or the particular features of the project is not adequate for risk management and probably not for cost management as well. Um, so that's the challenge on the people side. Now, in terms of technical level, I think that, as I said, the industry has evolved in this and has made a lot of improvements, but there's still work to be done. Thankfully, we're all still learning, right? So geology, geomorphology, I flag as an area. I think every mine that I know has awesome geologists who know everything about the geology of that area. But these people don't always support the tailings people in understanding the geology, so that's more like working across lines. But also for us geotechnical engineers, it's not only important to know the geology, but also the geomorphology. So a simple example here, the yellow is a sandy material, the purple is a clay material. So if we know in my world, maybe not here in Australia, that the clay has been pushed by glaciers and ice rusted, we probably could expect that they're shear plains, they're weak plains, and because we could also expect that in the middle of all that sand, there could be layers of that clay. So in, in tropical areas, like how deep is the weathering profile? Like I think in every place we need to go further than this is what the stratigraphy is today, but to understand how it got there is important. Hydrogeology is an area that we could go. Soil mechanics, a very solid basis in theoretical soil mechanics is absolutely essential. There are many brilliant professionals out there, several pockets of excellence, and in my work in ITRBs, I have exposure to that. But I also have exposure to areas that need to do better, to do more. So, in the reports of some of the recent failures have indicated that in several cases the knowledge existed, but it wasn't utilized. So that's very important. Now, to improve the technical level, our colleagues in academia play a very critical role in teaching this, the technical, the theoretical fundamentals that everybody needs to start their career in tailings. And here I want to highlight the difference between formation and information, because I think in this time of AI and Google search everything is pretty fundamental. So what I define as formation is the process of guiding a person to a deeper understanding of a particular knowledge area, its theoretical fundamentals, but also the development of perspectives, of ways of thinking and doing and knowing that supports the development of critical thinking. And that's very particular to different areas. Like a doctor would think slightly different than we do. So they need to learn how to think that way. We need to learn how to think our way. Now, information are the facts and the data that are already known or can be known. So technical formation is what needs to lead the development of a solid understanding of the physics behind the various phenomena, a clear understanding of the assumptions and simplifications of the mathematical approaches that are behind our tools. So we have awesome tools today compared to when I started, for example. Um, but it's also very easy today to punch in a bunch of numbers in software package and come up with a solution. Like we need to have the critical thinking and the clear critical thinking to set the problem right, to understand what is the math that FLAC is doing, what is the math behind the seepage program, or the water balance, or whatever it is, right? Or whatever software you're using. So we need to understand the limitations of the problem, the boundary conditions. What is the problem at the hand? What is the engineering question we're asking? What kind of solution answer we need? And on top of all that, you need an ability to report all that in a logical, clear, and concise manner. I don't think is going to do that for us. So we're going to use AI, but we need to do more than that. And these days, information is very easy to get. Formation is not. So we need to lean on our academic colleagues. We need to seek out mentorship. We need to lean on the senior people who have made their mistakes and learn the way. Okay, focus on closure. I think we made a lot of progress on that, but maybe we're not quite there yet to do closure the way we would like to do. Clara here can tell us all about it at the level of feasibility studies and designs, and I'm glad that we have professionals like her pushing, and others here in this room, like pushing this area ahead, because it can have a positive impact in many things, including the regulatory approval, the social, the public acceptance, and cost savings throughout. If you start right in the long term of the project, like things can be very easy. Okay, so in addition to all these, the technical and environmental issues related to closure, I think there are still open issues that we haven't really tackled very well. So the issue, for example, of transfer of ownership, maintenance and governance of sites in the very long term. So I'm talking here multiple decades, centuries even, when the mining company may not even exist anymore. So who's going to look after governance of the sites? So I think as a society and as an industry, we still have a lot to do on that. There are a few countries a little bit ahead of others, but I think overall we still have a lot to do on that. So it remains pretty much a challenge for us. And the last thing I want to talk about in terms of challenges is the regulatory environment. And I want to quote Professor Morgenstern here back in his DeMello lecture. That was 6 years ago, but I think the comment is still valid today, which should be a red flag for us, or at least a flag for us. He pointed out that improving the safety of mine waste impoundments relies on shared responsibilities and cannot be achieved by regulation alone. So if you met all the regulatory requirements, the fact of safety is 1.3, this and that, like that's not sufficient. We need to focus on the safety and the integrity of the facilities over and above meeting the regulatory requirements. We got to do that too, but that's not sufficient. And the regulatory system can support the process that we're all after here by getting updated to current standards. They also need solid technical knowledge. They need to establish meaningful minimum requirements for tailings design, construction, operation, and management. So there have been positive updates in legislation in some jurisdiction, but in a few cases, new regulations became excessively prescriptive and unfortunately not always technically appropriate. Sometimes they were regulators that didn't have the opportunity of this technical level or the exposure or the experience, were overzealous, and I can understand them wanting to do that, but overly prescriptive that, like even if it's technically correct, but overly prescriptive is not adequate because they cannot possibly cover all the complex and diverse aspects of our geology, of our operations, of our designs. And moreover, they tend to limit progression, technical development in our area. So we need to team up with the regulators and support them in supporting our industry. So I think I covered all of that. Yes, most of us know all the issues, the complexities of fact of safety. So jurisdictions that say you must obtain a fact of safety 1.5 or 1.3 or whatever the number is, but say nothing about which parameters go with that. Like we know, like I sometimes joke, if you want a fact of safety of 5, I can get you any number you want, provided you don't ask me about parameters. Okay. All right, lots of challenges to address, which is good because it keeps us busy, entertained, and challenged. But then, after all those challenges, I guess the question is, okay, where do we go from here? We all have our own crystal balls, our favorite pet peeves, and our different ideas, but I'll share what my crystal ball tells me, my perspective. In my view, we would benefit as an industry from a few things we could discuss. We need to, in my view, we need to work as a system. We need to focus on developing robust designs that are verified by performance data from well-designed and well-implemented monitoring systems and good instruments well installed. I also believe that we need to go beyond the consequence of failure classification that came to us from the water industry. I come from the water industry too. Beginning of my career was all hydropower work in the water dams. But I think for tailings, we need to move on. And we need to continue to develop approaches to risk assessment, risk management, and the use of LARP that is suitable to tailings facilities. So I'm going to cover, as I did before, each one of these 4 things in a bit more detail. But if you allow me a detour, let's talk about the revolution that we all have seen in occupational health and safety. What the heck? What is that all about? Well, there has been a revolution. In the past, the ones of us with a certain age all have done things that are completely unacceptable today. So things changed quite a bit in this space of health and safety. And it worked. These graphs show the number of incidents or fatalities in different countries over the last few decades. And you can see the trend is clearly significant drop in incidents and fatalities. So why don't we do the same for failures of tailings facilities? And as I said before, we're in the middle of a cultural change in our industry. So it's the perfect moment for all of us that are living in this space of change and extend this cultural change into working as a system, because this is how the health and safety people did. So, but what it is to work as a system? Oh, wrong way. Yes. Okay, sorry about that. Okay, so for us to work as a system, we need to start by recognizing and managing tailings facilities as a highly integrated and dynamic system with a high degree of complexity. So you probably, in a minute of thinking about all the projects you've been on, this is going to ring true. It is pretty complex. It's highly dynamic. Construction is ongoing. Mine planning is changing. All of that, right? So the tailings facility system typically involves many people in different groups with different objectives, different responsibilities. There's mine planners, there is overburden stripping, there is water balance, there is design, there is construction, there is operation, and everybody has objectives and also has responsibilities. And it's very difficult for people at a particular level within a particular group um, to have a visibility of what are the issues in the other groups. So threats to them safety can be far from obvious until a failure actually happens, right? So mine planners don't necessarily have the visibility of see the impact of a change in a mine plan scenario that's really good from their eyes within their area, that what these changes could do to things like pore pressure development in the foundation of the tailings facility and the assumptions that the designer made in terms of pore pressure dissipation. I can't reasonably expect them to know that and have that up front, right? Just to give one example. Also, a manager or an equipment operator that may not have a clear view of the impact of particular things in the field or in the situation. So we need to recognize that it is a complex system, and also we need to see that a combination of small decisions may not be seen as a whole with all its ramifications in everybody's areas. So, since dam safety is impacted by decisions, behaviors, actions of people all across the system, to be effective, risk must be managed using a system-oriented approach in a cross-disciplinary manner and using a robust approach to manage the changes. Because you can make a change that looks really good, but you don't know the impact it's having elsewhere. So that's why the GISTM also talks about and requires a solid change management system with everything is recorded, and also the changes are not accumulating and affecting each other. Good changes, two good changes together can have a negative impact. So we need to have a very good visibility of all of that. So sound stewardship and effective risk management comes from aligning people, knowledge, objectives, responsibilities in all areas across the system. So we need to identify that, and we need to work as a system. Several mining companies are already going along these lines to various degrees, but maybe it's worth us taking a quick look at what does it mean to work as a system. So here's a big list. We're not going to spend a lot of time. And by the time you dig into this, you're going to find out you're already familiar with that. Vertical integration, what the heck is that? It's like an integration from like operators, workers, all the way to the board of directors, supporting the same objective. So what is an example? Like we all have participated in safety meetings, safety shares, whatever you call it. In the last few years, almost every meeting starts like this, all the way from ITRBs, board of directors, to tailgate meetings before the work starts in the field, whatever you guys call here, tailgate meetings. So we all have done that, from the workers all the way to the board of directors. So we understand what vertical integration is. So in our projects, putting everybody together to talk about risk, to deal with that. Horizontal integration is what I'm talking about, is all the groups across, is the planners, the designers, the people in operations and constructions, and it's all across. So there is knowledge integration from all levels within the operation. There is a clear understanding of the roles of everyone. There is a very clear, accessible change management system. There is a clear, accessible knowledge base. So there's transparency in internal and external communications. So, there is a lot of literature out there in working as a system. Even I stuck my neck out a little bit as a geotechnical engineer. I have a couple of papers on this. So, and we need a strong governance to keep that framework and support that. So, besides working as a system, we also need to focus on developing and implementing robust designs that are verified by performance, data from good monitoring systems, and that are well designed and well implemented. But what is a robust design? Some of you might be asking. We'll spend a little bit of time on that because I receive a lot of questions on that. The GISTM says to develop a robust design is one of the topics, so I get a lot of questions on that. So it's the definition varies, but one definition that applies to us is a design can reasonably accommodate uncertainties and changes in mine plans and operation plans, and that can accommodate some degree of unexpected performance without creating undue risk or excessively interfering with mine operations. So a design that creates a situation where the mine has stopped operating, the plant has stopped operating, that's not a robust design in anybody's books. So it could create a risk, it could create performance that's less than ideal, but it can't have create an undue risk or excessive impact on operations. So it needs to be based on detailed understanding of the geological, hydrogeological, geotechnical conditions of foundations, abutments, the hydrology. It needs to address all physically possible potential failure modes with appropriate design measures. That does not mean a conservative design. That means a design that's addressing risks appropriately. And it needs to make use of redundant tools. Like we have tools these days from the computer and in the field that are good tools, but every tool has a limitation. So an example here, CPT is a fantastic tool. I'm a big fan, but it has a lot of limitations. So if something is really critical, we do a CPT test. Maybe we, as a clay, we also do vein shear tests. Good tool also has its limitations. If they both tell you the same thing, that degree of redundancy decreases the uncertainty. So that's an example. So having multiple tools really help a robust design. But there's other things. A robust design needs to include an appropriate selection of design parameters and associated factors of safety. It also needs to consider different scenarios. Sensitivity analysis. What could change in the mine plan? Could they extend the pit and need more height? Or no, that's out of the question, and that's out of the financial planning. Again, working as a system with other parts, right? But also the sensitivity analysis, so the designer can identify the uncertainties, the risks, and develop a design that's not overly sensitive to the uncertainties that are natural in our area, right? We also need a clear understanding that analysis is not design. I do a lot of reviews, and I have situations like people come and say, oh, I did my CPG analysis, 15 cases, stability analysis, FLAC analysis, so here's my design. No, that's not your design. These are calculations and tools that support your design. So we need to think more carefully. A design that is something that needs to be buildable, needs to be practical, needs to be buildable with materials that exist in the area. Operators need to have ramps, need to be able to access, otherwise it's a paper design, it's not a real design. So a design is something a lot broader. It needs to be calibrated to local experience, equipment. It doesn't help to design, I don't know, in the middle of nowhere with equipment that doesn't even exist and people who don't know how to operate that equipment. So it needs to be practical and calibrated. And then the monitoring needs to be monitoring the potential failure modes. It needs to be checking the assumptions you made in your design. So you can have a performance-based design that's adjusted as you learn about how the material goes. So all of this, everything that I just said, are important aspects of managing the risk of a tailings facility, right? Okay, I think we covered all that too. And we need to move beyond consequence classification. Some people think this is a bit provocative, but I hope I can convince you that it is a good thing to have it, but it has its limitations. So it's based on the fundamental approach. I think a lot of people here know what it is, but it's based on the fundamental approach that we analyze the potential consequence of a failure separate from the probability of the failure. So This is the table that's in GISTM. It comes from iCode's a draft in 2019. So on top of the table there, you may not be able to read, but are all the potential consequences. We classify according to all of these things: potential loss of life, population impacted, environmental issues, costs. These tables can vary a little bit. And then we say whether for each of these categories has a low significance, high consequence of failure. Whichever classifies the highest is the one that counts. So that's the top row. On this side, then we estimate the probability of that failure. And from there comes the consequence classification, which then determines the two external loads that must be accommodated in the design: the design earthquake and the design flood. It's a very common approach. It's everywhere, international regulations and all this. And it has its role, but also it has its limitations. So the terms of reference for the GISTM were that it was mandated that it had to be consequence classification based, but there are requirements in there that support us starting to go beyond that approach. So you got to use, but also let's think about it on what are the advantages. I think it has several advantages. It helps focus the governance and the regulatory approach on the facilities that have a higher potential consequence, which is good. It supports decision making. Also, it requires, the GISTM requires that the facilities with the highest consequence have to be brought up to the highest levels of the company, the accountable executive, the executive team, and the board of directors, which is good. It should be that way because that group is accountable. If a facility failed, they are in real trouble with the justice system and everything else. So it's fair that it goes to them. It's important that it goes to them. And they need to be part of the decisions relative to these facilities. Also, it is important because it prioritizes the work by the mining personnel and the consultants. And another advantage is that it helps prioritize expenditures, which can be particularly helpful in the situations, say, beginning of a mine is a good example, where the cash flow is critical. You can prioritize that. And what I mean by that, the facility, different than the water industry, the water dam industry, facilities grow with time. So in the first few years of the operation, the facility is like only 20 meters high. You can classify it lower. And then later on, when you have more cash flow, you can upgrade that to whatever it will be at the final crest elevation. So helpful, and these are significant and good advantages. However, the disadvantage, it puts undue focus on two external loading factors, seismicity and loading. It says nothing about the parameters, says nothing about anything else that controls the design. There's a lot of things, we've been talking about it from the beginning, that control the risk and the integrity of the facility, not to those two things. By the way, you have to go back many years, if not decades, or actually decades, to find the tailings dam that failed because of the wrong earthquake design criteria or the wrong flood. I can think at the moment, didn't think of this prepared the presentation, but think of this, the Chilean failures in the 1960s. None of the more recent ones. So then that's not good, that we do consequence classification and focus on those two parameters. So we need, and that's what makes me think that we need to use this too, but move beyond that, right? No matter what I say here, I couldn't be any more eloquent than Scott Martin, so I will read. We should not lose focus on addressing the issues that have been implicated in historical failures, which are lapses in governance, engineering, and construction quality control. Designing for the 10,000-year return period seismic loading and flood won't help if the site investigation didn't identify a critical weak layer in the foundation, if the tailings operations allowed slimes to encroach into the structural beach zone, or if highly contractive tailings are mischaracterized as being dilative. So addressing these issues is where our industry will have the greatest positive impact in safety, and slowly build confidence in the public and society in general that we can manage these facilities responsibly. So not that I'm against consequence classification, but we can't be too hung up on that. There's a couple of other disadvantages. I'll go quickly on that. It is frequently primarily focused on potential loss of life. And I think if we are instilling a safety culture that we prioritize life and don't accept loss of life, that's not exactly the right message to put across or the right focus to have. It's not acceptable to society. If you think society is represented by the judicial system or pressure from stakeholders or investors, that's not a good way to put things across. And even if in an alternate universe you were to assume that this is acceptable, we still face other limitations. As the mind progresses, you may start in a situation that there is no one downstream, so the potential impact of life is negligible, whatever, this and that. A potential impact of infrastructure, there's no infrastructure. And then you design for low significant consequence. Well, as time passes, the mind attracts jobs, the world evolves, the population increases. Next thing you know, there's a town downstream, there is bridges, hospitals, schools, and the mine owner has no control over this, no control over that. So you could paint yourself into a corner that you designed for a certain thing that's no longer valid. Now you have to retrofit the facility. And it's not always physically possible or economically viable to retrofit a facility, so you're stuck. So it's that's why the GISTM says, check your design for extreme consequence first. Because in my experience, there are many cases where the cost difference is not that big. It's a slightly bigger berm that when material is already available, the contractor is already mobilized, the equipment is already there. So sometimes NPV and net present value rules, but in many cases, the difference is not that significant, so you might as well. It's cost effective, it's better in many ways. Okay, it also creates difficulties communicating. It's very difficult to communicate to, especially if you're dealing, with getting more community relations and stakeholder engagement, to communicate that a facility that has an extreme consequence of failure does not mean that facility has a higher risk. That's not intuitive concept for a lot of people. Okay, so I think we covered all that. Okay, so my last comment on where I think the direction we should go is continuing to evolve risk assessment, risk management, and use of ALARP. An effective risk assessment is started by convening a multidisciplinary, multi-departmental group of individuals with decision power and or knowledge of the facility in detail. It harks back a little bit to working as a system. Nobody knows everything about a facility. But when this group like this is convened to identify and discuss all potential failure modes, their potential consequences, the mitigating factors, the probability of detecting a mechanism in time to halt it, the measures that can be taken to reduce the probability of the consequence or the efficacy of these measures, it's an extremely valuable exercise. Typically, it doesn't matter which method you use, qualitative, quantitative, semi-quantitative. That's getting together to discuss the issues, to share knowledge. In the situation of individuals, identify, rank, quantify potential failure modes and their risks. In the process, knowledge is shared, a lot of details are transferred, um, and the group emerges with an increased understanding of the facility, an awareness of the issues that could lead to poor performance, um, and various ways to operate the facility in ways to manage risk. In my personal experience, often that leads to working as a system a little bit, even if the governance didn't impose that, or if the governance did impose, it's an opportunity to test it out and say, hey, this is actually pretty valuable, we could do that. And in many cases, that experience is more valuable than the results of the risk assessment themselves, because now everybody is more empowered and more knowledgeable to manage the risks. And I have been in cases where from there, solutions came up that really effectively managed the risk and were quite cost effective, but were not visible to everyone because we're all in our little compartments and not working as a system, right? Okay, so that's extremely valuable. Um, and we could make a parallel back to them in the health and safety risk and how that was improved. All right. So we need to continue to improve our methodology to do risk assessments, recognizing the applicability and the value of each approach. Um, it's not about having a number. Oh, this probability of failure is 5.1 times 10 to the minus 8. It's something way more complex than that, and the qualitative aspects of it are very important. Um, I can't I can't talk more about how valuable the approach is and the understanding that's gained in this risk assessment project. So, and also we need to continue to discuss ALARP as low as reasonably practical, a tricky thing. Came from the public health industry. The applicability to the tailings industry is growing. Some organizations are doing better than others, but it's still a growing edge that we need to continue to pursue. So there is a lot to do. I think these points are important to consider as we move ahead. I'm sure other people's crystal balls are seeing other things. And I want to just thank you all for allowing me to share my perspective here.